Finding oblique asymptotes. So we've done vertical, we've done horizontal. Guess what oblique means? Yeah, it's a fancy name for slant or a diagonal asymptote. We get an oblique asymptote whenever the numerator is 1 degree more than the bottom. So 1 degree higher than, does that even make sense? Does that look like a fraction? Write that however you need to, but 1 degree higher than the denominator. So if 1 degree higher gives you this, what do you think 2 degrees higher would give you? What kind of asymptote would you have? Yep. We've got an x squared. What is an x squared function, John?
Makes it slow.
Yeah, so we could have an asymptote that looks like this. We're not going to go there this year, but we might next year in Math 1050. So it's just a little foreshadowing. All right, so oblique, fancy word for a slant asymptote. And there we go. When the numerator is exactly 1 more than the degree. Today, we're going to stop at quadratic over linear. We won't go any degree higher than a quadratic. First thing you want to do is you're going to factor anything you can factor, cancel anything out that you could cancel to see if there are holes. But let's look at this function. Are there 2 numbers that multiply to be 1 but add to be? No. Yes, and if I could have thought of 2 numbers that might have worked, I would have factored out that negative, Saxton. You're absolutely right. But even if I factor out that negative, there are no numbers that multiply to be -1 and add to be +4. So I know this doesn't factor. That fraction is in simplified form. And so this is how we figure out where that oblique or slant asymptote is. We divide. Now, if you can use synthetic division, I use synthetic division. You might run into some today that you can't, but this one we can. So -2, -1, -4, and 1. And so what is my depressed polynomial? 1x minus 2 plus 5 over, what were we dividing by? X plus 2 is what we were dividing by, right? -2 is what was in our synthetic division box. Says the quotient is the equation of the oblique asymptote, but I've got this funky remainder, and you get to ignore it. Did you ever think you get to hear me say something like that? You get to ignore the part you don't like. What? I know! But let me tell you why. There really is theory behind that. When we graph, can x get bigger and bigger and bigger and bigger and bigger?
Yeah.
In fact, it gets so big, 5 divided by that, as huge of a number as you can think of, gets closer and closer to what? 5 divided by the hugest number you can think of gets closer and closer to 0, or the asymptote. Yeah, perfect. So that's why we get to get rid of the remainder. So as x approaches infinity, is what that says, the remainder trends toward 0. So you get to ignore it. So I'm going to go ahead and I'm going to label everything I can here. I've got an oblique asymptote at y equals, we just divided and figured out that equation, right? -x minus 2. I've got a vertical asymptote where? What makes that denominator equal 0? -2. All right, so x is -2. There were no wholes because there were no common factors. And, all right, we have an oblique because it was 1 degree higher than the bottom. All right, so there's no horizontal asymptote. We've got an oblique instead. Go ahead and graph your vertical asymptote at x equals -2. I'm going to put on my glasses. And then let's graph our oblique asymptote. So my y-intercept is down 2, and then I've got a negative slope of -1 over 1. I'm going to cheat and use a straight edge. And make it dashed as well so that you can see that you have an oblique asymptote. Now from here, everything will feel pretty much the same. From your vertical asymptote, we're going to pick some values. So give me 2 values on the left-hand side of that asymptote.
-3.
I would choose -3. I think that's a great one. One more. -4. All right, so watch your signs when you're substituting back in. Square it and then negate it in this case, right? So I would have -9 plus 12 plus 1 over -1. You guys should definitely check my math. 3, 4, I get -4. Did anybody already substitute in -4? All right, you're waiting for me, huh? -16 plus 16 plus 1 over -4 plus 2 is -2. So I'll get -1/2. Now, Alex was having you only plot 2 points. Is that right?
Yeah.
It depends on the problem. Sometimes they wanted more.
One on one, like yesterday, the other day, homework assignment, you only had about 1 and then it would get.
How nice is that? All right. Well, I'll continue with plotting 2 at least then. So I have, let's see, -3, -1, 2, 3, 4. And then I have -4, 2, 3, 4, and -1/2. Did you guys get your question figured out? They're getting it figured out. Do you need me?
No, it's just small.
Okay. Sorry. That's just that's my scratch, I guess. That's just where I'm plugging values in. All right, so now let's do the other side. X, Y. I choose 0. You guys choose one more.
1.
1. All right. 0, I get 1/2. And then with 1, we get -1 minus 4 plus 1 over 3. So that would be -4/3. So at 0, it was 1/2. At 1, it was -1 and 1/3. And then you guys get the benefit of being able to just click the Graph It tool, right? But we just follow those asymptotes. That's all we do. When we do college algebra, we'll take this one more step and learn about where it can cross an asymptote, but we don't need to worry about that this year.
Good thinking.
Let's do one more together, and then I think you'll be good. Hey. My numerator is 1 degree higher than the bottom. So what do you know right away?
It's an oblique.
I'm going to have an oblique asymptote, and I have to calculate that. How do I calculate that?
By doing some physics.
Yeah, do some division. 1, negative 2. So I've got 1x plus 1, and I get to ignore the remainder. So I have an oblique asymptote at y equals x plus 1. Am I going at an okay pace? Slower? Where is your vertical asymptote?
Positive 3.
Okay, at x is 3. We know we don't have a horizontal asymptote because we just calculated an oblique asymptote. So let's graph those. There's my x equals 3. And the oblique up 1. Okay, and again, to the left and the right of that vertical asymptote. And I'll give you guys just a second because I can see you're still graphing those lines. Okay, on the left, I choose 0
And 1.
and 1.
Negative 1, right? Or
We could
negative
choose
2.
positive 1, negative 1. I might have chosen 2 because it gives me a denominator of negative 1, but does it matter? It doesn't matter, right? Some of the numbers might give us prettier points than others, but not really. So what did we decide? 2? All right. I plug in 0, and I get what, 2/3? I plug in 2. Here's my scratch over here. 4 minus 2 over negative 1. And so I get 2. 0 and 2. 2 and, oh, I did that wrong. That is not 0 and 2, it's 0 and what? 2/3. Now, as I was doing that, what made me really pay attention is I was going to have a point on one side of the oblique and then on the other side of the oblique. So I knew I'd made a mistake. So there's my 2/3 right there. And here is 2 and 2. Now this is what this one would look like. It's just going to turn around in there. Where do you think the other half of this function is going to fall? Like clear up here?
No. Not, yeah, right.
Right here?
There.
All right, let's look and see. Pick 2 numbers on the right-hand side. About 4.
4 and 5.
4 and 5. I'll plug in 4, and let's see. 16 minus 8 minus 2 over 1. That'll be 8, 6. If I plug in 5, 25 minus 10 minus 2 over 2, 15, 13 halves. Okay, we're going to kind of be running out of room on that graph, aren't we? So over 4 up 1, 2, 3, 4, 5, 6. And over 5 up what? 6.5, which would put it here. So that would sit in here. We didn't have a whole lot of room to get that. Who thought it would be in there? Couple of us? Okay. I do have a mixture of all of the problems we've been learning in there, so let me know if you get stuck.